Seniors, this is the last section of content for which you are responsible. So this will be the problem set this weekend, and then one more Delta Math are your last assignments for this class for the semester. We had talked about this already, right? Or no? Yeah? The end of the semester survey is up on My Notre Dame in the announcements for whether you want to take a doubled high test score or to retake a test. At your convenience, since seniors, you've taken all your tests you're going to take for me, please fill that out kind of when you get a chance so I can start entering those scores and figuring out who needs to take a final and who doesn't. And did I hand out study or exam study guides for seniors? Yes, you guys all got one? You didn't get one? Bella, did you say you need the one? Sure. Any other seniors need, have you lost yours in the meantime? Okay, very good then. So those are there. All right, before we get going on the new stuff, I guess, are there questions from homeworks or other things that we need to talk about before we get started on the new stuff? Nothing. Okay, then. So the plan for today, you know how we've been using our calculator every time we need to solve an exponential equation? That ends today. Today we are going to develop algebraic methods to be able to solve these things by hand, which is really exciting. So we're just going to I'm just going to go through and do examples. There's no new conceptual things that need to happen, no new definitions, or you have all the tools in place to begin doing this. Yeah, Ava? Sure. All right. So, the idea here is that we're going to want to use a logarithm to cancel out the base of the exponential, right? Just like we've done, like we developed in the last lesson. So before I can do that, though, I have to get the exponential piece alone on one side of the equation. So if I look at this problem here, 14 times 1/3 to the x minus 1 equals 126. I notice that the first thing I need to do is get rid of that 14 times the exponential. How do I move that 14 to the other side? I divide by 14. Is everybody okay? Now, what I want to do is cancel out this exponent base. To cancel out the base of an exponential, I need to use a logarithm. But as we've seen, there's infinitely many kinds of logarithms. Really, any of them will work, but there is one choice that is the best choice that makes this as simple as it can possibly be. What base of logarithm should I choose to make this problem as simple as possible? I want to choose to make the base of my logarithm match the base of my exponential. So I want to use log base 1/3. So I'm going to do that to both sides. And whoop, whoop. I know that log base 1/3 cancels exponent base 1/3. If that podium's in your way, Bella, you feel free to get up and drag it out of the way for you. If it's driving you nuts, no big deal. Is everybody happy with where I've gotten to so far? And then my final step, yes, sir.
You put this, like today's notes as the first ever. So
Oh, yeah, that's a problem. Thank you. Let's fix that, huh? There we go. We'll push that sync for you there real quick, Gavin. That should pop in there in just a moment. Okay. And now the last thing I need to do to get the x by itself is to just add 1 to both sides, right? Now I can't add that 1 inside the logarithm, so that plus 1 is just going to go to the end. And now it's going to just be calculator time. So I'm going to fire up my good friend, my graphing calculator, and I'm going to type into it just log base 1/3 of 9. How do I get the base to show up so I can pick any base I want for my logarithm? Do you remember how to do that? You have to press the math button, and then we're going to scroll way down to the bottom to find the log base command. And then I can just type this in just like it looks like on my sheet of paper. So my answer here is -1. What did you guys think on that? Is that okay? Not too bad, I hope. Let's do another. So we have the equation 12 times 3 over 2 to the x over 5 equals 27. First step should be to divide by 12. Now 27 over 12, that reduces to just 9 over 4. You don't really need to reduce it since it's going to go into the calculator at the end anyway, but we now have the exponential piece by itself. So I'm going to cancel out my exponent base using log base what? Log base 3 over 2. Excellent. And whoop, whoop. So I'm left with just x over 5 equals log base 3 over 2 of 9/4. And then the last thing I need to do to get the x by itself is 2. Multiply both sides by 5. You could divide by 1/5 also. That's not wrong to think about it that way, but yuckarooskies, I'd prefer not to deal with like fractions if I don't have to. And again, that 5 can't multiply inside the logarithm, so it just is going to go out front. And so we'll just go ahead and start typing. And I'm going to get 10. God bless you. You're welcome. So far, so good here, folks? All right, here's the worst situation. So this situation is going to be fundamentally different, at least at the beginning stages, than what we just have been dealing with. Let's take a look at it and point out, like, what is our cue that this is going to be a fundamentally different kind of solving problem. Take a look at this. We have 3 to the x plus 3 to the negative x all over 4 equal to 2. What here makes this a fundamentally different problem than the previous one? Well, that in itself isn't such a big deal. Like if that was just, if the previous problem was like, 3/2 to the negative x over 5, nothing would really change other than we multiply by -5 at the end, but big whoop, right? So it's not the negative exponent that's the big deal. It's that I have 2 separate exponential expressions in there, right? The x is in 2 different locations. Do you guys see that? That's going to make the solving a tad more difficult. So the first thing that I'm going to want to do is I want to get rid of the fraction part, because while I don't like the x's on 2 different locations, I certainly don't like fractions on top of that. What would I need to do to get rid of the fraction here? Yeah, just multiply both sides by 4 to clear the fractions out of there. Everybody okay there? Now, the second thing that I don't like about this is I don't like the negative exponent. That's not going to make life easy for me if I have 2 different kinds of exponents here. So what can I multiply to both sides to get rid of that negative exponent? Not a negative. I'm going to multiply both sides by 3 to the x. So 3 to the x times 3 to the x is just like 3 to the x squared. What's 3 to the x times 3 to the negative x?
9.
It's not 9. You ready for your minds to get blown? It's 1. So remember, when we multiply exponential numbers, we add their exponents, right? So that should be 3 to the x plus negative x, right? Everybody's okay there? What's x plus negative x? 0. And what's 3 to the 0 equal? 1. Oh, Mr. Kulak, you tricky dog. And then 8 times 3 to the x, what's that? Ooh, no. Remember, we can't multiply exponentials like that. It's just 8 times 3 to the x. I was setting you up to give me the wrong answer so we could circle back to that. Remember we talked about that like the first day? So what I'm going to do is I'm going to subtract this all over and get everything on one side so it's equal to 0. Is everybody okay there? Now, what I'm going to imagine is if I squint at this hard, maybe I'll rewrite this first. If I squint at this hard, this kind of looks like a quadratic equation to me. Right? Because I have something squared minus a constant times that something plus a constant, right? Do you kind of see that? So to make it more clear, I'm just going to pick a new variable name and replace all my 3 to the x's with that variable name. Because now I certainly have something quadratic. Can we all see that? So when you get one of these exponential equations that has the x's in more than one location like this is going to be the trick. Is going to be turning it into a quadratic equation. How do I solve a quadratic equation like this? There's 2 primary techniques we might use. Quadratic formula or factoring. Okay? Which one do you want to try first? That would be my choice too. Are there 2 things though that multiply to give us 1 and add to give us -8? I don't think so, right? The only things that are multiplying to give us 1 are 1 and 1 and -1 and -1. Neither of those are adding to give me -8. Guess what that means? Quadratic formula. So we're going to say y equals -b plus or minus the square root of b squared minus 4ac all over 2 times a. So -8 squared is 64. 4 times 1 times 1 is 4. So that's going to be 60 under the square root. But guess what? We're not done. Because we wanted to solve for x. What variable did we solve for here? Y. So guess what we have to do now? We have to put that 3 to the x back. Oops. So I'll break that into 2 equations because of the plus or minus. Is everybody okay with what we've done? And then how do I get the x out of the exponent there? What am I going to use? Starts with an L. It ends with an ithm. Logarithm. Which base logarithm should I use here? Log base 3. And it's calculator time. So math, log base 3 And then I'm going to use that horizontal fraction bar here. So there's one answer, which is about 0.87. And then if I just press second and enter, it'll give me the same thing back, and I can just edit that to a minus side. I get negative 0.87. I guess it's probably should round to 0.88. Those are the worst kind of exponential equations that we're going to run into, are those ones that really becomes a quadratic. But again, notice the pattern, right? I do some algebra to make it a quadratic, right? Then I kind of solve the quadratic. You're well, yes. Then I make it exponential again and solve the exponential. So that's kind of the, whenever you see that variable in more than one exponent, like we saw at the start of this problem, that's going to be the process. So you start by making it quadratic, solve the quadratic, turn it back into an exponential, solve the exponential. Does that feel okay? All right. Let's look at some logarithmic equations here. So very much the same idea in solving a logarithmic equation. What I want to do is start by getting the logarithm part all by itself. So right now I have 3 times log of x squared. What I need to do is start by dividing both sides by 3 so that the log is all by itself on one side. Everybody's good with that? Now, how do I cancel out a logarithm? Not an ln, that's just another kind of logarithm. So let me remind you guys. So logarithm cancels out an exponent base, right? So what's going to cancel out a logarithm? An exponent base. So the first thing I'd want to do is identify the base of this logarithm. What is the base of this logarithm? Because nothing is written there. It's not 1. This is the common logarithm. Whenever you are missing a base, we recognize that as base 10. So the exponent base that we're going to use is going to be exponent base 10. Oh my goodness. And again, I know it looks funny that I've wrote these exponent bases ridiculously big. I want to really emphasize we're not multiplying here. Everybody's okay that this is exponentiation and not multiplication? Pew pew. So what does x equal? If x squared is 10 squared, what is x? Nobody wants to take a risk? You're halfway. It's going to be, when we square root both sides, what do we get? Plus or minus 10. Now it looks like we're done, right? We're not. So for all logarithmic equations, we have to check for extraneous solutions, just like we had to for rational equations. Remember last chapter how we had to check? The check is going to be quite similar. The check that I need to do is, if I plug that x, my value for x back in, do I get a non-positive value in the logarithm? So if I plug 10 in, 10 squared is 100, no problem, that's positive. If I plug negative 10 in, negative 10 squared is 100, no problem. Both of these answers are correct, they both check out. That's all I'm checking, just to make sure when I plug it back into the logarithms, every logarithm has a positive number inside it. If not, discard that solution as extraneous. Does it feel good? Let's do another. Ooh, scary. What makes this one scary? It's what? It's long? This problem is fundamentally different than the other one because, not because of the ln's, because I have x's in different logarithms. We all notice that? So as soon as I see that I have x's in different locations, what I'm going to need to do is I'm going to need to make this a condensing problem. So I'm going to get everything onto one side to start. Everybody good there? Now, remember condensing, we did this last time. The first property of logarithms I use to do condensing is the power product or quotient. Power property is correct. When I'm looking in condensing, when I'm looking for a power property, I look for coefficients. I see there's one power property to do. So that allows me to move that coefficient in front of the logarithm to an exponent inside the logarithm. The next thing I look for in condensing then is product property. So in condensing, a product property is indicated by the addition of two positive logs, which I have there. So far, so good. And then the last thing I look for is a quotient property, which is indicated by the difference of two logs. So if subtracting, Does everybody feel good to this point? Now that I have this down into a single logarithm, I can cancel that logarithm. What do I use to cancel a logarithm? An exponent base. What is the exponent base for the natural log for an ln? It is log base e. So we're going to use exponent base e to both sides. Pew, pew. What is e to the 0 equal? 1. We're left now with a rational equation, just like we had in the last chapter. To solve that rational equation, I'd want to start by clearing the fractions. What do I need to multiply both sides of this by to clear the fractions? Well, I want to multiply by the least common multiple of the denominators, right? Which in this case is just x squared. So now I've transformed this into a polynomial equation. So to solve this, I want to get everything on one side, and I probably have to FOIL this thing out, right? I'm going to do that here quickly in my head. Does anybody object to me doing that? Okay. So now if I subtract the x squared from both sides, I'm left with this quadratic. To solve this, I can either factor or use the quadratic formula. I'm going to opt for the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Negative 5 squared is 25, and then 4 times 2 is 16. 25 minus 16 is 9. The square root of 9 is 3. So if we add those, we're going to get 8 over 4 or 2. If we subtract them, we're going to get 2 over 4 or 1/2. But we're not done. Because what do we still need to do? Check for the extraneous solution. So if I take the 2, I go back to the very beginning. If I plug 2 into here, I get 6 minus 2. That's a positive value. 2 minus 1, positive value. 2, positive value. My solution of 2 is acceptable. If I take the 1/2 and I plug it in, 3 times 1/2 is 1.5. Minus 2 is negative. Rut-row-raggy. That's not good. That's extraneous. And we'll discard it. What do you guys think? This is my stopping point for today. We're going to wait and do the application solving problems, like the story problems, next lesson, because if you can't do it without me writing the equation for you, it's going to be tough to write the equation then do it. Let's just chunk this a little bit. So you guys should be able to work on 99 through 130. And we're going to stop here. You guys can take the rest of the 45 minutes or so left in class to keep on plugging away at this problem set. Yes, sir. So I think for Sunday, this problem set 3, we have already assigned 37 to 68 and then 71 to 98. And then we're going to add on to it these 99 through 130. Seniors, this is the last problem set for you, is this stuff up through 130. That's it. We'll have one more Delta Math involving solving that I'll also ask you to do. That's it for you guys. Nothing past that. And remember that you have 2 dropped homework assignments for the semester. So if you have all of your homeworks completed to this point, 2 missings at the end will not affect your grade. So if that's you and you have all your homeworks done and completed, seniors, don't feel like you need to finish these things. Just kind of do enough to like, I got the feel for this. I'm good. You don't need to turn anything in. You don't need to complete that if you have already completed all of your assignments to this point. The 2 drops at the end, or 2 missings at the end, will not affect you because they'll just be your drops. Just reminding you, in case you got busy this week, that it's not a big deal. How's everybody feel? Okay? I know there's a lot of homework for this set. Not all these problems are terribly time consuming, and I'm trying to find lots of time to give you in class to keep, grinding away at this set, because I know that there's a lot of homework problems in this set. But again, this is the first time we're seeing this stuff, so I know that the practice is important. Okie dokes?
Sure.
Okay, I'm going to stop talking then and let you guys have at it.